Welcome back. We're going to keep building on our crop implementation by completing the harvest mechanic and spawning some lootable items. So we've got our crop resource, but we need to go ahead and create our item resources for our seeds and for the corn itself. Create a new item. We're going to name it corn seeds. And after this, we'll create the corn item itself. Next, we will manually add some items to our inventory here. And you can see if you click on it, nothing happens. You got to click the edit pencil, and there is no selection for what we're looking for. We actually need to select object, which is going to include resource. You can see at the top there. And at the bottom of the list, you'll see all of our custom resources. I don't know about you, but I've got some busy work fatigue. Which, speaking of, here's some more. We're going to go ahead and update our structures node name because really it's just objects at this point. It fit when it was door, but we'll add a rigid body 2D node to that, and this is going to represent our lootable item. So we'll rename that to lootable item. And of course, it needs a collision shape. So we'll just go ahead and give it a default circle shape. And I'm having deja vu, but we're going to need to add again a sprite 2D to display the lootable item. And we'll want to interact with lootable items the same way we do other things in the world. So let's go ahead and enable our YSort so it has that same perspective as all our other objects. That's it for the structure of our lootable item node. So let's go ahead and create our script. And pretty obviously, the first variable we're going to define is the item that we're going to be looting. And we want it to be clear that this is something you interact with, so we're going to give it a little animation to make that obvious for our players. To do this, we're going to utilize the tween class. And this is perfect for a lightweight animation where it's just moving in between 2 points. And just like our plot class, we will define a variable for our sprite, and we're going to reference the sprite within our lootable item node. We're going to define the ready function for this node. We'll assign our sprite texture to the item texture and create our tween animation. First, we'll make a call to create tween. Then we will invoke the set trans property, which is going to set the transition mode, and we're going to set this to cubic. And that's just setting an easing property for the animation. Then we're going to define a duration for the animation. And finally, we'll make a call to the tween property method. We'll need to pass a node, in this case self, the property, which is position Y. And then all we're going to do is adjust our Y position up and down so it's kind of bouncing out in the world space. Finally, we'll call set loops. And if you provide no argument, it will just loop indefinitely. Well, our animation's working, but looks like our YSort's a little off. So to make that adjustment, we'll just select our sprite 2D node under our lootable item, and then we're going to apply an offset just like everything else we've done for YSort. Now, in order to loot our item, we're going to have some way to interact with it. So we're going to add an area 2D node to our player. And no surprise, it wants a collision shape. I'm feeling lazy though, so let's just go copy the collision shape we made for our lootable item and put that under our area 2D. It would appear everything is good. Our warning has disappeared, but there is a small gotcha when you're copying resources like this. Our collision shapes are sharing the same circle. What we need to do is come into our copied collision shape and select make unique, and that will create a new identical resource. Now this first shape we're going to name attraction range, and any items in this zone will be attracted to our character. And we'll need some way to loot the items after we attract it to us, so we're going to need to add another collision shape, add another circle to that, and we're going to call this one pickup range. The collider previews can get pretty noisy, so change colors, toggle visibility, whatever helps you make sense of it all. Let's check out our new area and collision shapes and see what adjustments we need to make to it. Just gonna move our character off to the right, give us a little breathing room visually. Adjust the area position so it's centered on our character. The position is just -8 on the y-axis. And then just tweak the collider shapes to your liking. Anything is good enough for now. We're gonna make changes to this later anyways. Area 2D lets us define a gravity override. Select Combine from the dropdown. That will union all of our shapes for calculation. Toggle the point check mark, and then set the point center to 0, 0. So within this area, this point is the center of gravity. Let's give it a test. We'll move our lootable item out here, make it easier on ourselves. We'll fire it up and see what happens. Okay, so what? Where are you going? Corn. Well, besides the obvious attraction to the right side of our screen, there were some other issues that needed to be addressed. Adding a physics material isn't required, but it will help you fine-tune the feel aspects of your game. To the contrary, gravity scale will have a very immediate visual effect. Again, this is preference, set it to whatever you'd like. This is set to 0.3. Turn off can sleep so it's always active, and then we're gonna lock rotation so our sprite orientation stays correct. And we can see our areas actually had no effect on the item, it just kept going right. And that's because we need to set up our collision layers. By default, every node is assigned to layer 1 and interacts with layer 1. We're gonna give these some names. You can either select edit layers or get there from the project settings. We'll leave layer 1, label it as the default, and assign player to layer 2 and loot to layer 3. Double check that our lootable item is selected, then we'll adjust our layer to 3. As you can see, it now says loot. And then the mask is what we are targeting for interaction, and that will be 2, our player. Apply the inverse to our player area, so layer is 2, and then our mask will be 3. Player area was pretty vague, and this is a specific implementation, so let's just rename this to loot range. Let's see if that helped. And it looks like it's slowed down, but we're still not able to interact with it. Our collision layers and collision masks are set up correctly, but the tween animation we set up earlier still has control over our Y position, so our loot range has no influence on it. To remedy this, we're going to implement a stop animations function on our lootable item class, and this simply makes a call to tween.kill, and that will stop all of our animations. And with that in place, we are ready to create our script for our loot range. And our loot range is going to need a way to reference our player, but instead of using the node and unique names like we have previously, we'll define a variable player with a type of player, and this will allow us to create an explicit reference to the node that we are trying to target. We'll define a function to handle the detection of different shapes entering our area. And there are 2 ways you can detect that collision. You can detect the entire area as a whole or individual collision shapes that enter the area. We are going to be utilizing the body shape entered signals so that we can split our behavior between the attraction range and the pickup range. So just go ahead and connect body shape entered to our handle body shape entered function. And then we'll create 2 additional variables to reference our attraction range and pickup range. And we're following the same pattern as player for these variables, so make sure you define a type, and it is collision shape 2D. Then go ahead and assign those variables. Make sure you select the correct collision shapes, as there are many more than the player. And holding control, I'm going to click our signal. It's going to take me to the docs where I can copy out the function signature for the body shape entered signal. There are a lot of parameters here, but we're going to be focused on one, which is going to be local shape index. Local shape index is going to reference the shape with which our incoming body collided. We will check that the body is a lootable item, and if it is, we're going to compare the local shape index to our attraction range and our pickup range index. The attraction range will just be responsible for stopping the animations, as all of the gravity is handled within the config. And if our local shape index is the pickup range, then we are going to kidnap the item. And in order to loot our item, we will call player inventory add item, and then we will pass it the item that is attached to our body. And to remove the lootable item node from our tree, we're just going to call queueFree on the incoming node, and that will remove that node from the tree and designate it for garbage collection. And to test this, I'm going to go to our inventory script and I'm going to set a breakpoint on our add item function, and let's see what happens. Okay, so we hit our breakpoint, so add item was called. We're going to check a few things. We expect items to be empty still, and it is. Once we step over this, now we would expect items to have our item, and it does. But our player and our loot aren't overlapping, so why did we attract it when we fired up the game? Well, it's no surprise at this point, but we have some project settings to adjust. If you come into your physics 2D settings, you will see the default gravity vector with a Y direction of 1. These are great defaults for a platformer, but for top-down, we want to disable any of the default gravity. And if everything went well, you should have working lootable items. So we've got our lootable items, but how do we actually spawn lootable items? We can't just place them in the world and populate them without the user's interaction. So we need a way to create a reusable node from this node tree. And the way Godot handles this is by creating new scenes. So we're going to create a new folder called scenes, and then right-click our lootable item and save branch as scene. Just save it in our new scenes folder as lootable item.tscn. And at this point, you can safely remove that original lootable item node. In our global script, we are going to add a reference to our new lootable item scene. I'm going to keep this organized with a dictionary with the key of node, add an entry for lootable item, and preload our newly created scene. With that resource preloaded, we can now implement harvest on our plot. Define a function harvest, and we're just going to first check if our crop is harvestable. And if it is, we're going to create a new instance of our lootable item. The node first needs to be instantiated, so reference the resource and call instantiate on that. And then we'll assign our loot item to the crop harvest, which is a new property we'll need to define in crop. And we're going to export a new variable named harvest, and it's going to have a type of item. Make sure to update your existing crop resource and just populate that harvest property with the corn item that we created earlier. Assign the world position of our loot to the current position of our plot. Our loot's instantiated, but it's not added to our scene tree yet. So we'll add our lootable item as a sibling node by calling getParent, addChild, and passing our lootable item. And finally, we need to despawn our harvested plot. Invoke queueFree to remove it from the scene tree and designate it for garbage collection. Replace the print statement with our new harvest function, and let's see what we've created. And we should expect the behavior of our plot to be the same with the exception of our final harvest. So we'll just wait for our crop to mature, harvest it, and hope that we spawn everything as we expect. And I've given it an extra half day here just to make sure that we stay in our mature state. And if we click it, our item does spawn, and it is lootable. And to make sure that your areas are triggering and interacting as expected, you can select visible collision shapes from the debug drop-down menu, and that will give you some visual cues that will help make debugging easier. Next thing to take care of is the UI for our inventory. So we're going to add a new node to the camera 2D, and we're going to add a grid container. For now, we'll just implement a small inventory. It'll be more akin to an action bar or a hotbar. So we'll set the number of columns to 10, and then we're going to anchor this at the bottom. And then for our item slots, we are going to add a 9-patch rect. And this controls a specific type of texture rectangle. It enables us to use one texture and slice it into 9 distinct parts. That way we can use all those parts to create a resizable container. So I'm going to quickly design a little item slot container and then export that to our project. Now that we've got our item slot container exported, we'll just import that as the 9-patch rectangles texture, and then we're going to set the patch margin to 4 all the way across, so left, top, right, and bottom. And these properties correlate to the border thickness on that given side. And we'll want to set our minimum size to the canvas size of our original image, and you can see that it's quite a bit bigger than we want, but if we go and adjust our minimum size, our borders don't adjust with it, so now we just have a super thick, smaller container. And I forgot to add a backdrop, so I'm going to go ahead and add that to our item slot container. And we can toggle that backdrop on and off with the draw center property. You can see a little bit of the border disappears, so if you're going to toggle this and make use of it, be sure to account for that in your sprite. So if we're not adjusting the dimensions of our item slot container, how do we resize this? Well, the easiest way is just to scale the entire grid container. And as always, these values will be impacted by the other decisions and values you've made, so just adjust it for whatever fits your project. I've landed on 0.5, which may take up more room in your UI than you're comfortable with, but is helpful for display purposes, so I'm just going to leave it there. And I'm populating our grid container with 10 copies of our item slot containers just to see how everything looks visually. And then take a moment to reposition your grid container to fit within your viewport. Looks like everything is in working order, so let's just go ahead and rename our grid container to inventory, and then get rid of all of those extra item slot containers. And we'll rename our new 9-patch rect to item slot. And the first child we're going to add to our item slot node is going to be a margin container. I am again just defaulting to 4 all around. And we can see our size has adjusted, but now we are off center. So just adjust our anchor preset to the middle anchor point. And we'll need a node to display and select our items. So we're going to add a texture button. And the texture button is a bit unlike anything we've used with textures before. You can see here we've got 6 different options for textures. As you can see, you can enter different textures for the different button states. For now, we're just going to use the normal texture. We'll go ahead and load up a normal texture so we can see what it looks like visually. I'm just going to load the tile overlay selection because it's already an individual sprite. As you can see, our texture is tucked up in the left-hand corner there, so we're just going to change our stretch mode to keep aspect centered, and that will stretch and fill while keeping the aspect ratio locked in. And this node will be renamed to item button. And once you're happy with your setup, go ahead and clear out that texture, and then we are going to save our item slot branch as a scene. And now you can safely remove that item slot from our main scene. And similar to our lootable item scene, we're going to need to add that to our global resources. So open up that global script and then add a key for item slot. Next, we're going to implement our inventory script. So create a new script called inventory_GUI on the inventory node. And we're going to need a reference to our player as well as a list of the current item slots. And the event-driven architectures provided by Signals is perfect for user interfaces, so we'll just simply define a handler and then listen to the player inventory for any item added events. And typically user interface is going to be considered a lower priority than game mechanics, so we're going to call connect deferred, which will lazily connect our handler to the signal. And the logic for our signal handler is quite simple. We just want to find the first available empty slot, and if there is one, we'd like to populate it with our incoming item. And the easiest way to go about this is to define a custom comparer. So we're going to define a function called findFirstEmpty that accepts an item slot. And our comparer will return true if the item in our item slot is equal to null. Well, we have an item slot scene, but we haven't made the class for it yet. So let's go ahead and reopen that item slot scene and get that added. Once open, you should see the scene browser is changed. Just right-click the item slot and add a new script item slot. Define a class name item slot, and then we will fill this in as we continue. Reopen your inventory script and you should see that our error has gone away. Item slot is recognized now. So let's finish up that implementation for handle item added. We'll find the item index by searching item slots with find custom and passing our custom comparer. And I'm adding an assertion to check the item index here. Just by nature of the design, we should always have an empty slot available here if we have just filled an empty slot in our inventory, but we can't find anything unless we have something to search. So let's go ahead and populate our item slots array. We'll just iterate from 0 to the inventory's max capacity. Define a local variable for our item slot, and then we'll instantiate our item slot scene that we defined in our global resources. And we'll assign the item slot's items to the corresponding inventory slot items. We'll append the item slot variable to our item slots array, And just like our lootable item, we've instantiated it, but it is not added to our scene yet, so we will call add child item slot. Now let's continue with our handle item added function. We'll make a runtime check on our index similar to our assertion, and if it all passes, assign the item slot's item to our incoming item. Now let's go ahead and flesh out our item slot class. Of course, the obvious variable here is going to be item. And I'd like to design this item slot so that it works with both a hotbar and also in an inventory window. So we're going to add a string variable of inventory position. It should actually be item position. This is a typo. And we'll need a couple reference variables for our child nodes. We're going to need one for the item button, which is a texture button. And then we're going to need a variable for the hotkey label, which is just a regular label. In the ready function, we will just set our hotkey label text to our inventory position, and then we're going to connect to the pressed signal of the underlying item button. And then quickly stub out that function signature just to quiet the IDE. And we'll define a custom signal for this item selected. And this is effectively a proxy of the press signal, with the difference being we are going to also emit the item. Everything looks good, but there's a small difference between this scene and the lootable item scene we created earlier. The main difference is the life cycles. A lootable item is created and meant to be destroyed rather quickly, whereas a user interface is persistent throughout the entire session. With the current implementation, we're not able to change the item at runtime. It would only load what's there at the beginning. So instead of implementing a bunch of individual getters and setters, I'm going to focus on the setter for the item specifically. Add a colon after item to define setters and getters. We'll start with a getter, which is very simple. We're just going to return the item in this case. And in our setter, we're going to make different decisions based off of the incoming value. If the incoming value is null, we'll just clear out this item slot. Otherwise, we'll set the item button's normal texture to the value of our incoming item's texture. And to make it a little more readable, we're going to set our item value and then access item.texture. And then just a quick update to the inventory script, assign the item position on item slot equal to our index plus 1. Next, right-click on Objects, click Instantiate Child Scene, and then we're going to select our lootable item. And a quick intermission for me to fix inventory position to item position. And of course, don't forget to populate the references on your item slot class for your item button and the hotkey label. Now it's time for the moment of truth. Let's see if we can loot an item and have it appear in our new inventory UI. Well, that's a good start. We've got our item slots populated and their hotkey labels. And our loot showed up. Awesome. I'm going to make some minor visual adjustments to our item slot UI, but that concludes part 4. But a quick update for those of you who have followed through the series so far. I've got my new marketplace project Gadget Godot in the works, and I also have different types of videos I'd like to make. So for full transparency, the next part is not my top priority, but is still a high priority. Thank you all so much for your support. It means the world to me. Please like, subscribe, comment. I appreciate all the feedback.